Hello my friends, welcome to Incident Electronic channel. It's Uncle Misha, and today we have a bunch of junk. It's not junk actually, it's a very important thing for someone. And this someone gave me this thing while I was picking up at his place this thing. It's very interesting, right? So it turned out to be someone has nostalgic, gentleman has nostalgic connection to this device. And this device is, if you see it, it's a milkshake device, right? This all come together. The problem is, I think there is an issue with the motor. It's not working. Today, the person actually completely disassembled this device in order to understand what the heck is going on here. But what we're gonna do, I think the whole problem lies with the motor. So we're gonna take a look, at this motor and this coil, and I think it's look like a little bit charred to me. All right, so we're gonna kind of take a look closer here to determine if this thing is Gonski or not, because this bearing is definitely almost Gonski. So together we're gonna quickly understand if this motor is salvageable or not. So we're gonna definitely remove just those two. This is gonna go back. I'm gonna use this little piece of paper towel to clean up my hands. Yeah. Alright, so this is so-called universal motor. It doesn't really smell that bad. I kind of try to sniff it to see if it's actually burned. So bottom bearing is actually in good condition, but this one, let me kind of zoom in for you. This one look charred. So yeah, so today we're gonna kind of measure this to see if it's all if these wires are not burned. Yeah, they feel like they burned. I don't think it's looking good, honestly. I don't think it is looking good. So on this side is the, oh no, okay, this is not burned. This is just a black material used to wrap the coil. So there is no permanent magnet here. So this is a AC-driven magnet, and this is AC-driven. This is starter, AC-driven rotors. Okay, so this is universal motor, but it's specifically done for the AC application. Okay. So what we have to do here, so obviously there is no polarity, so personally I think try to mark the polarity, but it doesn't matter in AC world. Okay, let's just undo this one. Okay, so what we're gonna do, first of all, we try to measure the, we can try to measure inductance, by the way, which we can't using this device, but I have something to measure inductance. So let's measure capacitance, resistance first. Let's understand if this, let me move it a little bit closer to here. That's all dirty. Let's measure first of all if we don't have short between any of these commutator pads and the armature. If we have short between these guys and that, it's pretty much game over. This means it burned and it's shorted. Okay, first of all, let's check continuity. Okay. Need to find good contact point here. Is this good? All right. This is what I'm doing with any of those, which each of them, or try to do as many as possible. Technically, I can just do this, right? Because it can be short in different parts. Can be short in different parts of the armature, right? So those wires, if there is it burned and it's shorted to the armature in this, and there is no continuity further down. So essentially, have to check. I think this is very useful to check. Just double checking. I just had the little noise here. Okay, already done few loops, and looks like there is no short between this and this. And it's also kind of important and measure the resistances of each of those guys. Oh my god, this is... It's higher. Higher. Anyways, looks like it's gonna be okay. So we have to deal with this bearing as well. It looks like it's just... It rotates, but like barely rotates, so we need some kind of lubricant here. Maybe in the meantime, while I'm poking around, I add some... silicone lubricant is not the best lubricant for this. Add some lubricant for it to penetrate for now. I have this kind of lubricant in this container, so sometimes I use it on my 3D printer. So in the meantime, I'm gonna just add this like around here, because it looks like this is the open bearing. Maybe it needs to be changed, but for now... Oh, it's already way better. Oh my god. It spins. Spins way better. Okay, it's super dirty. Okay, let it work. Let it do its magic. Now let's look at the starter here. So starter consists of two coils, okay, one coil and second coil. They create a magnetic field in this starter, two coils, and there is also brush holders. So one coil connected between brush holder. Oh, there is also a power switch, so it's just on-off switch. Okay, so essentially we have brush holder, coil, switch, and another brush holder and coil. Okay, so in order to understand if these coils are fine, we have to do the following. We have to understand between what brush we have to probe. So now it looks like the wire going to this side of the coil, to this coil, so coil number... And another wire goes to the switch. So we're gonna check. Let's shut this down. There's gonna be some certain resistance we need. Oh my god, it's so hard to get in there. Whoa. That's the... Okay, 11 ohms. So it seems like a reasonable number, 12 ohms. Now let's check this side of the business. And where's the... Okay, so it looks like between this and this wire. About 10 ohms. So there is a difference in 2 ohms. I don't know if it's significant or not, but looks like two coils are fine. So I have strong suspicion that this jazz is operational. Let me try to put it together, because let me see if this bearing... Not sure how it's really supposed to be going, but it's... Look at how nicely it spins now. Yeah, after I lubricated that bearing quite well. So I have to understand now where is these guys, where are they matching? Aha, here we are. So this goes like this. Okay. Oh, it springs. Where is this springing? Oh, there is a spring in there. Oh, now I got it. So under this, right down there in the very bottom, there is a spring where the bearing lands, and it actually pushes it backwards. But that's all right. So we have to secure it like this. Those two wires are connected straight to the mains, and we need to also put the brushes back on. But let me secure this guy first. Right? You know what? I'm kind of thinking maybe I'm just gonna clean up this commutator before I put it all back together. Let me do that first. Don't do this anymore. For cleaning, I'll be using a little bit of alcohol and a bronze brush. It's not like it's really critical or anything. But the electrical contact will be so much better. Everything is shaking. Okay, that's much better and nicer looking. Looks like obviously there's a lot of scoring of this commutator with the brushes, and I hope the brushes is long enough. That's another how can I say, a fear, because if they are not long enough, this is all kind of doesn't make sense. Otherwise, I need to look for brushes. Let me get those screws and I put it together. Okay, we have those longish screws. That's the longest I can find in the box of parts here, and I assume they come. Are they? It's a game of aiming right now. Okay, looks like we are aimed correctly. Old school flat heads or slot screwdriver required. Okay, I have to make sure. Nice, spins nicely. Okay, so let's put some brushes on. For brushes we have this. I'm not sure what this is about. Okay, brush number 1. goes like that, not like this. It's very important to put it properly. Okay, brush goes like so. Then there is a brush holder, goes back on. Now another brush, it goes like this, because it's spinning this way. Okay, not 90 degrees, otherwise it's gonna mess up the brush. Okay, our brushes are in. That's at the end of the story. This is pretty much it. Oh my god, my hands are so dirty. So let's check the resistance now, because this is now supposed to have some resistance. Yeah, so it is going through. It is going through one coil, through one brush, through the starter, through the rotor coil, then going through another, how do you call it, brush, through another coil and going out here. You understand? Like electricity go or current go in here, through the brush, maybe first, well, through the switch actually first. Where's that switch? Here. Okay? So this is how it's supposed to be working. So what you can do, you can actually try to connect some piece of wire here and just give it a try. I'll prepare this. Alright, couldn't find nice piece of electrical wires which could just I can just pigtail these guys. I just decided to, you know, connect it straight here and then bother with it. Okay, let me do that quickly. So we have this, those screws obviously to mount this thing on here, and these guys are to, I hope I'm gonna be able to wash my bench after this dirt. Okay, so how would you do that? Probably something like this. Okay, so this wire will be wrapped around here. Obviously, the most convenient way is just to use this super dangerous holders. And where's the another one? I don't really like them, honestly. I would prefer, I'm probably gonna freaking solder it and just shrink wrap it. Or, yeah. Okay, but for now, for testing purposes, that would be sufficient. And those two are supposed to be hidden. Oh shit, you see? Why are they hidden? Unless it's so old they're just not holding anymore. Fuck that shit. I'm gonna just use electrical tape. Heat shrinking would be a better idea actually if I think about it now. Oh, we'll be back. Okay, I actually decided to go with heat shrink, so this is less ugly. Less ugly and more temperature resistant. Probably a little bit overkill on the heat shrink side, but nevertheless. I don't have portable heater, by the way. That's why I have to do this. It still works, just not as nice. Okay, okay. Let's push it all the way in there. Still want to use these two screws, because if this thing is not properly secured and I power it up, I'm pretty sure it's gonna jump all over the table. Because it's probably super torquey, I assume. stubby screwdriver. Okay, on this side. It's a beefy screws here. Okay, yeah, it's a moment of truth. Oh, it's very short cable. Okay, it's not working just because I think my outlet right here on the side is shut off. Just don't know where it's on, where it's off. It's kind of hilarious. It's powered on. Okay, let me... There is a switch here. Ha! Looks like my camera actually for a second shut down because this thing probably created a lot of like AMI interferences. Wow, electromagnetic interferences. Yeah, I don't know if you actually saw this, but like screen and camera and microphone actually was throwing some kind of errors. Yeah, but anyways, I don't know, was it like AMI or through the cable AMI or actually through the air AMI, but it clearly was the problem. Oh! Looks like this switch is not on off. Look at this. Yeah, looks like this thing is actually throwing some electricity spikes, because when you shut down the induction motor like that, there is a spike. When you start it, there is a spike. So anyways, okay, hey Paul, looks like your thingy is working after all. Yeah, here we are. Well guys, I think that's gonna be it. I don't know, maybe this thing was not even broken. It was, they definitely need, the bearing needed some help, like for sure, but rest of it was actually completely operational. So yeah, that's gonna be probably it. So now we know how this old Milkshake device was operating and what's inside, and if you have issues, how to fix it, and or at least to understand how to diagnose it. Hey guys, I think this is gonna be it for now, but please stay tuned for more videos and don't forget to subscribe, like and comment. I'll be happy to hear from you. Stay safe, stay tuned, and ciao!